Oh, I don't think I'm recording yet. Watch out, dude. Sorry. Oh, I am recording. Come on. 1, 2, 3. Hello, my fellow arcade enthusiasts. Come on, you gonna come up or we're just gonna sit there? Today, we're getting ready to, since the Daytona 500 is rained out, which I was looking forward to. I'm a NASCAR fan, so it's looking like it's going to be rained out for a while anyway. So I'm going to start working on the next in queue, which is an Asteroids board. So another Asteroids. I've already unpackaged it and it's on the bench. It's not hooked up at all. I just kind of looked it over a little bit. And initial impressions, it has old sockets. And with EEPROMs, that's probably going to be a problem. So those will probably be replaced. It's easy enough just to replace those. So we'll probably do that. Right? And we'll go from there. Get it working. Should be fun. Shouldn't be too difficult. Don't know anything about this board. Don't know what it's doing. So we're going to figure that one out together. So we'll I'll set the camera up over at the bench. We'll hook it up. We'll hook it to my oscilloscope first, and we'll see what it does. So let's head on over to the bench, hook that thing up, fire it up, and see what it does. All right. Okay, I got this board all hooked up, and I got my logic probe hooked up, ready to go. I'm going to turn this guy on. Should be a dot in the center. Maybe. Okay, there we go. There's our dot in the center of the screen. I'm going to turn it on and see what happens. It's all hooked up. And it just, the dot moves. So this isn't doing any, the board's not doing anything. So I'm just going to turn this off. We don't need the dot burning that thing up. I'm going to go ahead and hook the camera up on the tripod and just start doing a little poking around. How about it? Concentrate on this area first, I guess. All right. See what we got. Reset. Reset is held low. We have a reset is held low. We have an LS04 right here. And here's a crystal. There's like no life. Which, I mean, it's held in reset, so. wonder if this thing's... Nope. You see that reset button works. See that? So it's not the reset button. It's the reset circuit. Which on an Asteroids, I have to look at the, I don't know. I have to look at the schematic. Kind of curious about this chip right here. Yeah. I'm kind of curious about the crystal. There's no clocking at all. There's no clock. 6 megahertz, there's nothing. We got a total clock failure here. Yeah, 6 megahertz, there's nothing. Yeah. Okay, I'm going to have to look at the schematic. I want to pull out the schematic and look at the very beginning. Look at the clock. Seems to be a total clock failure here. There's no life. Kind of weird. I'm going to turn it off for a second. And I'm going to remove this chip. And let's just turn it back on. That chip was replaced. Yeah, I got to look at the, I'm going to have to just look at the schematic and start at the clocking, follow the clock. There's no life. Okay. I just want to I want to look at this LS04, actually look at it and see if it's just got a really low 12 megahertz signal, because sometimes that'll show up as a low on the logic probe itself. So I just want to verify that. I want to verify that there's no clock at all. I'm up here on the scope. Come up here and just kind of just take a look at the scope. Okay. Yeah, that's just low. Yep, nothing. Absolutely nothing. Nope. Thank you, scope. All right, next stop, I have to look at the schematic, so let's back this off, and I will grab the schematic, and I'll be back. Okay, we are now recording. I just put together a microprocessor slash clock. Yep, clock circuit. I just put this together, big old schematic. I'm going to try doing this, no interruptions. It's filming straight through, no camera breaks. I'm trying to do this just a straight up, one shot troubleshooting session. So I do want to find my plug to plug in the camera so it doesn't die. Yeah, this is going to be, you know, a lot of dead space and stuff. You'll just have to kind of pick your way through it if you want. I'll just leave it raw, kind of unedited in time. Real time troubleshooting is what I'm calling this. Plug this in, might shake a little bit. Okay. Don't want the camera dying, so I plug it in. Okay, we're back at it. So I want to put these two sheets up. And this is my clock, and I don't have my glasses. Okay, I'm sorry, but I have to go in the house, or the mainland as I call it. I need to go to the mainland, get my glasses, and then I'll be right back. I am not going to leave the camera running while I'm not here. So while I'm here, I'll leave it running. So that's the deal. I'll be right back. Okay, I am back, and I just dropped my glasses right on the ground. Nice. They're okay. And I made a cup of coffee because, you know, I want a cup of coffee. So, where is this camera focused? Right there. Yeah, let's do that. Get a little bit of me in there if you kind of see what I'm doing here. Okie Fadoki, Arctic Chokey. Alright, what do I want? Okay. Let's turn this guy on. Yes. Let's turn the board on. It's on. And we get nothing up there. Remember, this thing is completely dead. So what I want to do is... Can you see the scope? You cannot see the scope. Let me move forward a little bit. I'm going to come up here. I can't back off any. Let's do this. I want you to be able to at least see this scope a little bit. I'm going to fire it up. And you know what? I'm just going to go ahead and zoom in a little to this guy. I'm going to give you a view of the scope. This is a little bit annoying. Okay, give you a view of that scope. I'll just have to kind of tell you what I'm doing, what I'm looking at. I'm going to get to the clock circuit. Okay, this board is turned on. Okay, I'm going to go ahead and start right here. Here's the clock circuit. I'm going to go ahead and start with B5, this 04. I'm going to probe around on this 04, which is oscillating this clock crystal. That is B5. B5, which has been replaced. So somebody knew that this was dead and they replaced this 04. I want to look at pin 11. There's pin 11. Let's do auto measure. Okay. You see it's kind of there a little bit, but not really. And that's out to pin 10. And you can see that there is 12.06 megahertz. So there is our clock. That comes over into pin 13 and out here. There's 12.06 and then 9 out to 8. And that ain't good. 9 out to 8. That don't look good at all right there. So being that this has been replaced, this 04 has been replaced, and I did put this 04 in my IC tester off camera, and I know this 04 is good. So the next thing that is connected to pin 8 is C4, which is a 9316 counter, which is a 161. That's C4 161, and that's the clock on pin 2. So I'm going to go ahead and say that this chip is no good. So let's go ahead and turn this thing off. I'm going to turn the board off. And I'm going to just clip pin 2 off of that 9316. Pin 2 is now clipped. I'm going to turn it back on. And let's look at pin 9. And it's still garbage. C4 pin 2. That doesn't go to anything else. Okay, I'm going to have to remove this work. So I'm going to do a couple of things here. I got to remove this work that's been done, and I will show you this. Just give me a second to get this stuff out of the way, and we'll We'll position the camera here so that you can see what I'm looking at. I'm going to go ahead and turn this off. Turn the oscilloscope off. And I need to, the board is turned off, correct? No, it is not. Now it is. Let's unhook our probes and unhook the board. Okay. Now let me kind of back this up a little bit. Bring you down a little bit. Back a little bit and back in. Okay. This chip here is 04 that oscillates that crystal. This has been replaced, you can see. So what I'm going to do is I'm going to remove that work. This is the clip. I chipped the pin on this guy. I clipped the pin on that guy. I'm going to just replace that chip. I'm going to pull the socket out of the board here and I'm going to inspect around pin 9. The only thing pin 9 does is goes straight to pin 2 of this guy. Pin 9 just goes right to pin 2 of that guy. So there's got to be something funky in between there. And I separated pin 2 of that chip off of it and it was still goofy. So my guess is it's just something within the on the board in that trace. That's my guess. Yeah. So I'm going to go ahead and remove that 04 again. And I'm going to, oh shoot, oh goodness. Yeah, this has to be removed. I did not notice this. You see that? That stuff there. Yeah, I'm going to have to remove all of that. Remove all of that, repair all of that. Because that's where our issue is. So I'm going to grab my gun. Grab the old gun. Plug this guy in. Let's back this up. Just go back. Unplug. Unplug. That's plugged in. Yeah, that's gonna hold our problem, I believe. How's everyone doing today? Today is Wednesday. It is the 17th. 2/17. And here comes the furnace. That's the only work that's been done on this board, though. That's the only thing. So we will fix that. Because we've got our clock. It's just that coming off of pin 9, it's gone. Start removing some of this old junk. Let me grab my Twizzlers. Gotta love fixing prior work. That one's not even soldered. That is not even soldered. How weird is that? Good thing about when the furnace is on, it sucks so much air that way. When I'm doing this, it pulls that right to the furnace, right to the filter. Filters it. You'll see the smoke when it comes off of here, it goes that way towards the furnace. So that's actually a plus. Probably not quite hot enough, but plus if you suck up solder that is made with a heavy rosin activated core, it tends to plug these things up. I use solder that's made with a no clean wick, no clean solder flux. It's so much easier on your equipment, and it's better on the board. This one does not want to desolder. Does not want to desolder. And I'm going to go ahead and desolder and remove this guy. Let's just get rid of this guy. Casualty of war. Collateral damage. And what have we got here? That looks good. No. This one, I tell you right now, this was had a broken trace. And that might have been shorted to, this was a mess. That's for sure. You know. Yeah. This one, I guarantee you this was not connected. We really got to. This is a situation where I will be soldering this chip right into the board because I can make the connections better that way. So I'm just going to pop this guy right down in there. I need to plug in the soldering iron. This is where a socket just will not do for this. There's too much brakes, too many brakes in there and stuff. So I will plug in my iron, fire it up. Make room over here. Okay. Yeah. I need to solder this one top side because the pad is gone on the bottom, and then the trace is kind of broke on top, and I know that was not connected before. So I'm going to solder it like so. And that has made that connection good. Didn't need to do jumpers and stuff all over the place on this. Just didn't need to. Yeah, there was no need whatsoever for any jumpers. But we do need to make sure a couple of these are done top side. Like that. And that is good. Yeah. Now I am going to put a socket in for the 161. So I will grab a socket. 16 pin. 16 pin socket. Okay. And we will solder that. And as I always say, never solder a socket in with the pins folded over to hold it. Always straighten those out, because you never know, you might have to remove this, and it's a lot easier to remove it if you don't do that. So, alright, let's clean up our mess a little bit. Or their mess a little bit. More like it. It's always easier to see what you've done if you clean up after yourself. Todd just texted me, guys, and he said, quote, and I quote, this is his text: "I think you need a Cinematronics test rig next." What do you guys think? He says, "I have all the gear you need." That's a real-time text right there, guys, from Todd. Hooking me up. He's trying to hook me up with Cinematronics stuff. What do you guys think? I know what my answer is. Hell yeah. Alright, I need to plug in. It's going to get loud and noisy in here as I got to plug in the air compressor. Shoot. Yeah. I guess I'll do it. And plug your ears. Going to make sure that this connection is indeed made. It is. It is. Okay. Let's pop a new 161 in here. I can put this up for now. We grab a 161. I'm almost out of 161s. Only got 2 left. That's not acceptable. Okay, 161 in. Oops. Put this on one. This up here. This up here. Okay. This. That over here. Twizzlers. That over here. Garbage. Kinda clean good. Parts. And we need to hook all of this back up. This is Y. X. Ground. I gotta unplug the air compressor, plug in the oscilloscope back in. Okay. That's all hooked up. Let me hook up the power stuff. This. That's right. That's right. Okay, just for giggles, I'm going to hook the scope back up just for giggles, in case I want to look at, in case I'm getting the exact same thing, basically. Because there's a good possibility that, yeah, I don't know why that would continue to be funky. But, we'll see. Parts. Oscilloscope is hooked up and turned on. This is ready to go if I need. Let's go ahead and fire it up. It looked like it was doing something different. I still don't have. I still don't have no clock count. Interesting. Turn it off. I'm going to remove this 161 completely out of the circuit. Turn it back on. And it's still. I'm starting to think maybe this is a crystal problem. I don't know. Really. Strange. People are strange. Oh, look at that. Well, that's kind of strange, isn't it? Now I have my clocks. If I remove this, I still have my clock. If I reset it, I'm going to turn it off, turn it back on. Now look at that, see? Got that stupid little... Now if I put this over it, and I get my clock. So, turn this off. Dang it. You know what that's telling me? That's telling me that this chip is no good, even though my IC tester said it was good. Some crap. Alright, and it's going to change my strategy. I gotta get the gun back out. Now I'm going to have to, and I'm going to socket that stupid thing now. I'm going to heat that back up. We're going to have to remove that again. And I'm going to socket this 04. I'm going to take this 04 out. Because it's not, it just said it was good, but it's not, apparently. That'll come out really easy though. That'll desolder super easy. I'm going to go ahead and message Todd while we'll wait for that to heat up a little bit. Good old Todd. Okay, well, let's see if we can remove this thing now. I told him, I texted Todd and I told him, yeah, I was filming when you said that and I mentioned it. And he's like, really? I said, yep. He says, when you gonna post it? Hopefully today. Hopefully we get this repair done today. At least in the next couple of days. Okay, you should. The third one up might need to be done a little bit better. Well, there goes the pad. It came out pretty good. Yeah, really good. I'm going to have to just replace or repair this trace with a wire down through the hole. So that way, if I put a socket in, I know it's fixed. Oh, shit. People are strange when you're a stranger. When you're strange, people come around. When you're strange. Yeah. Come on. I might have to remove this capacitor. It's in the way. Damn thing. I do. I gotta remove this stupid kit. C17. C17.1. 0.1 microfarad. Okay, now I can, oops, now I can do this. Perfect. It's like a brand new trace. Okay. However, where'd that wire go? Did it drop? Drop it? There it is. I also need to make one for the power rail. Because I don't quite like what that looks like. Okay. Give that a good solder. All right. Now I need a 14 pin socket. Nice new one. Now I've got two trace repairs done on here. One's on the actual power rail. I soldered a wire to the power rail, put it down the hole, and then that one on the side there, I put a wire down through there soldered to the trace. Yep, let's look. I'll let you look at it. I'm going to unplug this, shake it up a little bit. I'll show you what it looks like, and then I'll put you back on the stand. This guy right here, we have this soldered trace, soldered to the trace here, and it goes down the hole there. And then right up here, I got a lead soldered to this 5-volt rail and going down through the hole. So that is that, and then I'll replace this capacitor. It's a 0.1. I had to get it out of the way because it was right across that trace. So put that back there. I'm going to plug the camera back in. Okay. And now go ahead and solder this guy in. Okay. Cut that wire coming up through that, that through hole. Straighten my two leads. Okay, that's done. Cut that power lead coming through the through hole. Alright, 0.1 microfarad capacitor, which is over here. Okay. Okay. And let's clean it up. Okay, it looks good to me. I'm going to go ahead and put this 04 in it. Okay. I want to just kind of okay. Now, you know, baby steps. I just want to see a good clock signal. It's okay if it doesn't work right now. I just got to have a good clock. Okay. I gotta get all reset back up. This is my X output. This is the ground. Alright, yeah. This is X out. This is Y out. And I gotta unplug the soldering iron and plug in the oscilloscope. Turn on the oscilloscope. Hook this oscilloscope up. Okay, get it ready to go, need be. Get this out of here. Okay, and, well, I gotta plug everything in. Okay. And we are turning it on, parts. Okay, it's still not working, but What's going on with this? Auto measure. Yeah. What the hell? It's saying 150 megahertz. What's going on? What's going on here? Turn it off. Let me grab a different 04. That was crazy. Do I have a regular PTL 04? Oh, not this. All right, turn it on. What in the hell is going on? .06 volts. Not a problem. Okay. Okie doke. Next thing's gonna happen is I'm replacing the crystal. Because it doesn't make sense. Things are not making sense. Parts, yes. What in the heck is going on? I'm gonna get the gun back out so that we can remove this crystal. It's such a simple little circuit. There's only a handful of things it can be. There's only a few things it can be. Yeah, just a crystal. And B5, a 470 resistor, 470 ohm R32, C18 is a capacitor. We got two 330 checking out resistors. There's 330. And this one's 470. Yep, they're good. I don't know about the 1 microfarad capacitor. I'm going to replace that too. The one that's in the circuit. Not the one that I already... The one that I already replaced is a bypass. It's just a decoupling cap. Now the other one is actually in circuit with the clock. So I might as well just replace that. It's a 0.1. Couple 0.1s. I'm actually going to take this bypass. I used a big chiclet type. I'm actually going to replace that with a nice little axial cap. While I'm doing it, it's better that way. So we'll replace those two guys. Okay. We'll replace that guy. I don't have the proper tip on here, So, well, we got it. I highly doubt that this crystal's bad. Yeah, you never know. We'll know pretty quick. Okay. Okay. Alright, we're good to go now. We don't need this anymore. But I do have to plug in the soldering iron. I gotta unplug and plug in, plug in, unplug this, plug in that. Okay, turn it on. Let's do the two capacitors. Okay. Solder these guys. I kind of want to refill in this via. And our 12096 crystal. Okay. 12096 crystal. Gosh, I could almost put this on the back side, but I can't because there's no soldering on this side. So okay, new crystal, replace those two caps. Unplug the soldering iron, plug the oscilloscope back in. Okay. Looking good. Plug this baby in. Okay, parts, good. X, Y, ground, my scope. Okay, get everything plugged in right. Okay, parts, turn on the scope. Okay, here we go. Still nothing on the scope. Now we have a clock. 6 megahertz. It's beautiful. Six point 0.04 megahertz. Yay. Yay. Still no video. No vector video at all up there. We got a reset rolling. Yeah, CPU is resetting. Okay. Hey, we finally got a step. So what I'll do is point you up here and you can see our clock working. Alright, remember pin 9 off of this 70, the 04 was like really low and garbagey? Now, that's it. So this is now what's clocking, and that's 12.096. Perfect. So that comes over and clocks this 161 that I replaced, and here's the output bits from the 161. The first one is 6 megahertz, which is right here. That's 6 megahertz. And then the rest of them are just half as the prior. So this is 3 megahertz. 1.5 megahertz and 750 kilohertz. Perfect. Okay, we're good up to there. Then we need 3 kilohertz and 12 kilohertz off of B4, which is that guy? Where's B4? B4 is this guy. So let's check. Pin 8 should be 3 kilohertz. 3, 4, 5, 6, 7, 8. You gotta zoom it out, zoom in a little bit to it. And that is 3 kilohertz, 2.95. And pin 10 is 12 kilohertz. And that's 12 kilohertz, 11.8. Sweet. That's our clocking. So let's take a look at, while I got this here, let's back you up a little bit and kind of zoom you out a little bit and down a little bit. There we go. I'm going to continue to look at the power reset and watchdog counter circuit. And it is B6 is an LS14. Let's look at B6. B6. Let's look at 12 out to, or 13 out to 12. And that should be high and low out. And then 11 to 10. Good. Now let's look at C6. C6 is a 0, 0, and this is the watchdog, basically the watchdog counter gate. 4 and 5 out to 6. 4, which is watchdog clear, which you can see we are not getting a watchdog clear signal, so that's got to be software related. Because we should be getting a watchdog clear signal. And then pin 5 is just held high. And 6 is low. So that's actually continuously clearing this counter. So watchdog clear is missing, which is an active low signal. This signal is missing. Yeah. NMI, non-maskable interrupt counter. I just want to look at that really quick. Make sure it's doing its thing. C5. Okay. Pin 15. Looks good. There's your non-maskable interrupt. Actually goes through an inverter, so we need to look at B5, 5 out to 6, and that looks good. That's your NMI on pin 6 of the CPU, right there. So that looks good. So we have a decoding problem. This is address decoding. It could be software related. I want to look at something. I want to look at pin 4. This is, I'm just going to kind of mess around with the ROMs a little bit. Okay, I don't believe it's a ROM problem. I think it's just a decoding issue. I think we got a decoding problem because this should be pulsing. So let's look at where is that address decoding. We're looking for watchdog clear comes off of L6, which is a 42 decoder. L6. L6 is a 42 decoder. Let's look at the inputs to this guy. So we're going 15, 14, 13, and 12. 15, 14. I want to go back up to 500 nanoseconds. Yeah. 500 nanoseconds. Yes. Okay. These are address bits. So that's good, address bits. And then you got 12, which that I guarantee you that is a bad signal. Because it's high all the time and I don't think it should be high all the time. It just looks kind of crappy too. It could be that way though, I don't know. But that's because that's high all the time, it means that this is always selecting the upper range of this decoder. Which one, because that's the most significant bit. So it starts at 8. So it's going to be 10, 11. See how 10 is pulsing there? 11's probably pulsing. No, it's never doing that one. It's not doing pin 9. Yeah. Output 8, output 9. That is a BCD decoder. So it'll only do 0 through 9. And it's only selecting 8. Which, I mean, it's going to, because the most significant bit is always high. So let's go backwards and look at E5, which is a 20. E5. It's this guy. The high side of E5. Okay. Pin 14 is always high. 13, I meant. 13's not doing anything. It is a NOT AND gate. And a NAND gate, the only time you'll get a 1, a 0 is when they're all 1. The only time you'll get a 0 is when they're all 1. So, let me look at 13 again. 13 is never high, so this is never, the output will never be low. So we need to move back. Why is 13 never high? Pin 13 comes from the LS02 at D6. 5 and 6 out to 4. D6. 5 and 6 out to 4. And that'll always be low because pin 6 is never low. Pin 6 is never low. But 5 is. Okay. So pin 5 is from the 139 at E4, and it's doing something. Pin 6 is always high, and that is signal R, not WB. R, not WB, comes from B2, which is an LS244. B2. B2, which is an LS244, pin 2 out to 18. Pin 2, I'm telling you right now, this LS244 is no good, because the output of this is 18. Well, then we got a bad trace. This pin 18 is supposed to go straight to pin 6 of D6. D6, pin 6. Is right here. Pin 6, D6, right there is high all the time. D6, pin 6, R slash not WB, R slash not WB. 2 out to 18 on B2. 2 out to 18. Alright, I gotta turn this off. How is that not connected? to D6, pin 6. Do we have a bad schematic here? R, not WB. R, not WB. D6, LS02, pin 6. D6. B2, pin 18. D6, pin 6. Where does that go? Where do they got that going? They got it going to C6, pin 9. This is not a correct schematic. D6. Oh, 34986. Yeah, it says 034986. But it clearly R not WB is pin 9 and pin 6 on here, but is also supposed to go to pin 18 of B2. Okay, it's going to pin 11, 12, 13, 14, 15, 16. It's going to pin 16 of B2. It's just not right on here. That is not right. It says that R not WB is pin 18 on the schematic, but it's pin 16 on the board. That's enough to give you a headache right there. That is enough to give you a headache. Well, let's plug this thing back in. I'm not going to bother with hooking up the probes and whatnot. Let's just fire it up and hook up my logic, my scope. And pin 16, 11, 12, 13, 14, 15, 16. 16, right? Okay. So that would be that's read write. Okay. Which 11, 12, 13, 14, 15, 16. Okay, that would be 4, pin 4. So there is no read-write. Alright, well there is no read-write signal, which means that there's probably it just doesn't want to run. So I think what I'm gonna do is I'm gonna put the fluke on it. I'm gonna put the fluke on it and check decoding that way. Because it looks like we just have an access issue to ROM. I don't think we're accessing ROM at all. At least we have signs of life, guys. That's good. We got our theta Theta 2, I should say. We have our 6 megahertz. Read-write is not read and writing. I want to put the fluke on this thing and see if I have access to the RAMs and the ROM, the RAMs and ROMs. I probably don't, would be my guess. But that's pretty frustrating when you're going through looking at a schematic and it doesn't match. You know, it's pretty irritating, to be honest. So I'm going to turn this off. And I think I'm going to end this video. This is going to be part 1 of the video. Part 2, we'll start off with the fluke. It's enough for today.